Hello, my name is Zinurov Vadim. I am a postgraduate student of Kazan State Power Engineering University. The subject of work is catching fine-dispersed particles and rectangular separation depending on different process parameters. Currently time, there is a need for development of devices for purification of gases of particles less than 10 microns in size. The effectiveness of nowadays existing devices in this range is extremely small, or their cost is very high. Ignoring of the subject leads to body height of incidence to losses of valuable components, which when catching can be raised also to short life of charges. Especially the problem is relevant for many thermal power plants where is the main fuel refinery coke, coal, peat, and other types of solid fuel is used. Now gas emissions are cleaned from solids as follows. At first, gas is purified from particles to 10 microns in size in devices of rough cleaning, as which cyclones, dust chambers are applied. Then the clean gas stream from coarse particles comes to devices of thin cleaning, where there is a cleaning of fine particles less than 10 microns in size. As devices of thin cleaning, electrostatic and back filters are used. A lack of such approach is that eventually devices of thin cleaning are hammered and their effectiveness falls. Hydraulic resistance of devices also increases. There is a need for cleaning of devices or replacement of their expendables that leads to a stop of the technological line of gas switching. These shortcomings of such approach decrease in effectiveness eventually and economic losses when replacing expendables and stop of technological cleaning of the line of gas. Therefore, increase in operational endurance of secondary filters is an important task. For the solution of a goal where the separator which is preferred to be installed to the device of thin cleaning that it will allow to increase overall effectiveness is developed and to increase endurance of devices of thin cleaning. The developed separator is presented on a slide. On a slide. Assembly of the device requires only 5 accessories: plates, cross plates, housing, hairpins, and nuts. The blocks, the T-shaped of elements who gathers by and insert each other plate and cross plates forms a basis of the device. Plates for the separator are carried out in the path also curve of metals, or the press on the third printer are flexible. Currently time, the test piece of the rectangular separator was made in just earlier. The principle of operation of the device is that when deriving a dusty gas stream between T-shaped elements, there is a centrifugal force rejecting particles to elements, thereby beating out them from the structured stream. Particles stick to walls or settle on the bottom of the device from where they are removed. The work objective is to study the influence of various process parameters on the efficiency of the developed rectangular separator. Development and creation of the separator was made by numerical settlement and pilot studies. Numerical researches were conducted in the program ANSYS fluent complex. When determining optimum ratios between constructional elements of the device, the following fixed parameters, which are presented on a slide, were set. For definition of an optimum ratio between length, the T-shaped elements and their ledges was inserted the non-dimensional coefficient of K, which was determined by a formula 1 as the relation of a ledge of the T-shaped to its length. During numerical model operations, the equation which solution showed that at K equal 0.25, the maximum efficiency at minimum hydraulic resistance is reached was received. That is, length of an element has to be 4 times more larger than ledge length. Also, various forms of elements were considered: T-shaped elements, P-shaped elements, and arc-shaped elements. During the analysis of the obtained data, it was established that there are 3 duties of the rectangular separator. The first mode at a speed of gas stream up to 10 meters per second. The second mode from 10 to 15 meters per second, which is transitional from the third to the third. And third mode at a speed more than 15 meters per second. Hydraulic resistance of the rectangular separator also depends on a form of elements, T-shaped, arc-shaped, or P-shaped. At a speed of gas stream up to 10 meters per second, that corresponds to the first duty of the separator. Hydraulic resistance of the device is on average equal 14, 15, and 16 when using arc-shaped, the T-shaped, and the P-shaped elements, respectively. The efficiency of capturing fine particles with a density equal 1000 increases as the inlet gas velocity becomes large. At a gas flow velocity of up to 15 meters per second, the average efficiency is 75, 73, and 70% obtained for T-shaped, arc-shaped, and P-shaped elements, respectively. As regards gas flow velocity over 50 meters per second, the separation efficiency of fine particles in the rectangular separator is more than 99% when using any shape of the elements discussed above. 3 operation regimes of the separator are specified depending on the gas flow velocity, which affects the efficiency of capturing fine particles from gas by their density. The most effective velocities of the gas flows for capturing fine particles are less than 10 meters per second, since these values correspond to the first separation regime, and hence its hydraulic resistance is minimal. In the case of the separation process of particles with a relatively low density, for example, density equal 1000, it's recommended to add several rows of elements to the separator, which increases the device efficiency at gas flow velocities up to 10 meters per second. When the gas velocities exceed 15 meters per second, the hydraulic resistance of the separator increases by 36% on average, which is a much larger value compared to the additional 1 or 2 rows of elements. Thank you for your attention. Так, заверши.